ऑनलाइन क्लास और सारे डाउट क्लियर।
Hello everyone, welcome to the class. Just give me 1 second, I'll check if I'm online and then we can begin. Okay, so in today's class we're going to see combinations of resistors. So before going ahead with this chapter, we will first once again have a quick recap of what is resistor, what is the resistance, right? And basically we will see what are the combinations of resistor, right? What happens if you connect resistors in series and what happens when you connect it in parallel. As soon as we finish that, we are going to see a lot of numericals from the same. Alright, that's the target for today's class. So with that note, let's begin the class. My name is Mohana. I'm a physics educator here at Unacademy, and I'll be basically taking you class 11 and 12 physics. And if you see, you can join me through the Telegram channel over here, as well as any update that we have would be shared in my in my Telegram channel, so you can follow me there. As well as this is the common ICSE and ISC both channel, so you can just follow this channel as well. Okay, hello Ashutosh. And just like how we have the classes on the YT platform, likewise we also have free classes on the Unacademy platform, and those we call as special classes. Now you can take any of your favorite educators classes for free. You can engage with the educator via pool feature that we have on the Unacademy platform, as well as if you have any doubts, just like this class, special classes are also live classes. You can get your doubts clear then and there. So go to the description box. The upcoming special classes for this month will be given. So you can just click on class 12. It will take you to the it will basically take you to the upcoming classes. You can just click on notify me. So before any class goes live, you will be informed. Now the upcoming class is on 26th July. It is at 7:45 p.m. and on this topic we are basically going to see a quiz on moving coil galvanometer. Basically we are going to do this unit 3, right? Sorry, from your unit 2, moving coil galvanometer. All topics that are covering under the moving coil galvanometer, we will see a quick recap. Okay, if you have any doubts also, you can see, you can ask. So you can join this class. Now the advantages if you're taking the plus subscription is that you can learn from the comfort of your home, and whenever you're taking a plus subscription, you will get 4 subjects, that is physics, chemistry, math and biology. Okay, so you will get unlimited access to all 4 subjects. Now if you take so at Unacademy, all the educators are really good, and every 4th session, okay, let's say today course is starting, every fourth session is going to be a doubt clearing session. Okay, then so and then you in the plus subscription you will get an exhaustive coverage of the entire syllabus. Okay, and also there is more practice test available, and every other week there will be a live test series. So after the live test series, there will be analysis session with an educator where you can actually get all of your doubts cleared if you got any questions wrong, and you can also ask in case if you want to know how to solve a question in easy ways, that also you can ask. Okay, the upcoming batches and classes I will tell you shortly. Now the price, if you see with Unacademy, the longer duration you take the course, the price per month goes down. For example, if you take for 1 year, the price you will be paying is 1,653 rupees per month. Or if you take only 6 months, you have to end up paying 2,204 rupees per month. So always with Unacademy, take the course, always take longer duration. Okay. Now, whenever you take the plus subscription, right now what we have is a 20% offer. That is, for example, if you're taking 9 months and above, if you take 9 months, you have to pay only 14,615 rupees. This is for all 4 subjects, physics, chemistry, math and biology, and you will be saving 2,578 rupees. Okay, and in 1 year time, if you see, if you're taking for 1 year, you have to pay 16,863 rupees, and you will be saving 2,975 rupees. All right, so this offer is till 29th July. Okay, and to avail this offer, you can use my code MTIS10. All right, next is whenever you're taking, okay, the ongoing plus batch that we have right now is the achievers batch, and the target of this particular batch is your midterm syllabus coverage. All right, so anything, the syllabus will be taught in English, and if you take physics, the course timing is between 5:15 to 6:15 p.m. every Monday, Wednesday and Friday. Okay. Math, Rahul sir will take chemistry, Manisha ma'am will take, Lakshay sir will take biology. Okay. Now, whenever you're taking a plus subscription, as I said, there are 4 subjects. So in a month, there will be minimum of at least 10 classes for each subject. So overall, more than 40 classes per month will be there for all 4 of these subjects. Okay. Meaning at least 10 classes. It could go to 11, 12 or even 13 likewise, but minimum at least 10 classes will be there. Okay. Now, in case if you're, other than this, there are test series available, and as well as you will actually be getting your like your live test series and everything. Okay, so you can use my code MTIS10 to take the 20% off that we have till 29 December. Okay, the focus of this batch is your midterm syllabus coverage. Similarly, for class 11 also we have the Brahmastra batch. So this batch starts at July 6th, and the course will be taught in English. For physics, we meet every 5:15 to 6:15 p.m. Tuesday, Thursday and Saturday. Okay, now if you are in the class 11, you have an advantage. You have to take the class 11 subscription. Class 12 subscription is absolutely free for you guys. Okay, so you're paying for 1 year and you get 2 years course. All right. Now, before we go ahead, a simple question is, what is the unit of resistance? We have ohms, ampere, farad and volt. So here the unit of resistance, if you see, is actually ohms. Okay, unit of resistance is actually ohms. Now, on that note, first let's see what is actually a resistance. Okay. Now, sorry, just a second. Right. All right. So, let's say you have a conductor. Any conductor, you can be a light bulb, fan, anything, any load that you're connecting. Okay. A conductor, right? This particular, if you connect a conductor, across that, let's say you're connecting a battery. Right, positive and negative terminal of a battery, right? This particular battery, if you take, the current flow will be in this direction. Now, if you increase the potential difference, right? If you want to see what is the potential difference across this resistor, you have to connect a voltmeter. Okay. Now, if you want to measure the current, you have to connect the ammeter in series, right? Now, if you increase the voltage, the current in the circuit also increases. See, V is proportional to I. Okay, so the current flowing through a conductor is directly proportional to the potential difference applied across its ends, provided the temperature and other physical conditions remains unchanged. Okay, now to remove this proportionality constant, we introduce R. All right, and this R is called the resistance of a conductor. All right, so this statement is basically your Ohm's law. Now, whenever you're talking about resistance, the resistance of a conductor is the property of virtue, okay, by which it opposes the flow of charges. Meaning, if there is a flow of charge, if whatever is opposing that flow of charge, right, that is what we call as resistance. Okay. Now, for example, if we have we know that V voltage is equal to I into R, right? From here, R is what? V by I. Now, if you increase the resistance value, or if the current through the circuit is less, okay, then what will happen? Resistance will increase. Okay, if you increase this current value, resistance will decrease because they are inversely proportional. So, the more the resistance, the less is the current I for a given potential difference. Okay, now this particular resistance we can say is equal to the ratio of potential difference across the applied ends of the conductor to the current flowing through it. All right. Now, from here, if you take what is the SI unit of resistance, it's very simple. It's ohms, 1 ohms, right? So we know resistance is equal to, in this case we saw voltage by current, right? So 1 ohm is nothing but, okay, if you take a resistor of you can say a particular conductor had a resistance of 1 ohms, right? If you apply a 1 ampere current is flowing through a particular circuit, right? And the voltage difference across the ends of the circuit is 1 ohm. Let's say you have a resistor, okay, a conductor, okay, and you are and here in this case the current flowing through the circuit is 1 amp, right? And if you connect a voltmeter over here, the potential difference, right? The potential difference applied across the ends of the conductor, what you're seeing is 1 volt. Okay, then this particular resistor has a value of 1 ohm. Okay, that is your value for resistor. Now, the resistor does not depend on the resistance is independent of voltage and current. Okay, but resistance depends on certain phenomena. Okay, resistance depends on resistance is proportional to the length of the conductor. Increase the length of the conductor, resistance will go high. Okay, and resistance is proportional to area of cross section. Decrease if you increase the area of cross section, resistance value will again go low. Okay, they are inversely proportional. To remove this proportionality constant, we use a constant rho. This particular constant is called as resistivity. All right, and it has a unit of ohm meter. Okay, so resistivity you can given as resistance into area of cross section by length. Okay, and resistance also depend on the nature of the material. All right, so this part you need to know. Now, next is whenever you use talking about the resistance in a circuit, right? In an electrical circuit, there will not be just one resistance, right? There may be combination of multiple resistance. Now, instead of using 2 or 3 resistors in a circuit, if you can replace that with one single resistance, okay, such that because you're replacing it with one single resistance, okay, there is no change in current in the circuit and in the potential difference because across the terminals. Okay, then such a single resistance is called as equivalent resistance of the combination. All right, so let's say I have in this case there are various ways in which you can actually combine resistors. One is in series, another is in parallel. Okay, so when you're saying a resistor is connected in series means it's very simple. Okay, in series means in this case whenever you say a resistor is connected in series, then it is actually connected in such a way that the resistance are connected one next to another. Right, let's say this is R1, R2, and let's say this is R3. Okay, now this is connected across the ends of this battery. Okay, so voltage is applied across here. Now current flow will be in this direction, right, from the positive to negative terminal. Now if you see what is the current flowing through all of these resistors over here, current flow across all of this resistance is same. Okay, but if you connect a voltmeter across all of these resistors over here, if you're just connecting a voltmeter to check what is the resistance value, voltage value over here, right, there is a voltage V1 over here, right, and within these two gaps, this particular voltage difference, this will be a separate value, right? This potential difference across this resistor will be different from this resistor. Potential difference across this resistor will be different from this resistor. Okay, but if you see, current through the circuit is going to be same. All right, so here what we can say is from Ohm's law we know voltage is equal to current into resistance, right? So here if you see, you just take if you see, for each of this resistance current flow is same, right? So but the final, let's say this is 5 volts, this 5 volts, the sum of these 3 voltage will be equal to this voltage, this 5 volts over here. So V will be equal to V1 plus V2 plus V3, right? According to, so the sum of potential difference across individual resistance will be equal to the potential difference we applied. Okay, so here V1 will be what? V1 will be what is the current flowing, okay, that is I, into what is the current flowing through the resistance R1, right? Potential difference developed across the resistance R1 when current I flow through it, right? Similarly, V2 will be what is the potential difference developed across this resistor when current I flows through it. So that will be I into R2, right? V3 will be I into R3. Now, instead of using these 3 resistors, if I use a single resistor and this single resistor produces the same current, same potential, right? So that is the combination, right? That is instead of using 2 or 3 resistors, if you are replacing it with a single resistor, and when you are replacing it, there is no change in current in the circuit, and the potential difference across applied between the terminals of this combination, that also there is no change in it. Okay, then we call it as an equivalent resistance, right? So this particular equivalent resistance, if you take, right, this is your equivalent resistance R, right, and current flowing through the circuit is I. Now this particular equivalent resistance will be the sum of all three voltages, right? So that will be basically V. So this V is actually nothing but current I that is flowing through the circuit into the equivalent resistance. That will give you the equivalent resistance value or the voltage over here. Okay, and from here we can actually say the current. See, from here what we can do is we can take I commonly outside, right? And if you take the equivalent value, you will get R1 plus R2 plus R3, right? Now instead of just 3 resistors, if there are n number of resistors, okay, then the equivalent resistance in this case for series combination, right? Equivalent resistance for series combination will be sum of individual resistance. So in this case, Rn, okay, in this case what we say is 3 resistors, right? For example, let's say this is 1 ohm, this is 2 ohms, and this is actually 1 ohm again, okay? Then if you take the equivalent resistance in this case, this will be sum of all of these values, 1 plus 2 plus 1, that is equivalent resistance in this case will be 4 ohms. This will be a equivalent resistance. So instead of using these 3 resistors, in this case you can just use an equivalent resistance of 4 ohms over here. Alright, so what are the laws that we're seeing for resistors in series? One is current through all of the resistors is same. Whatever the potential drop is, the total potential drop that we are seeing is equal to sum of the individual potential drops. That's what we began the equation with, right? Now, individual potential drop, if you see, they are actually individual potential drop V, if you see, is proportional to R, right? Individual drop, potential drop of all these resistors are proportional to individual resistors. Okay. Next is equivalent resistance. When you're taking, it is equal to the sum of all of these individual resistance, right? Equivalent resistance is equal to the sum of all of this resistance. So when a number of resistors are connected in series, their equivalent resistance is equal to the sum of individual resistance. Okay. Now equivalent resistance whenever you're taking is always larger than the largest individual resistor. Very simple. Look at this value. See, in this individual resistors value over here, if you take 2 ohms is the largest individual resistors, in this case 2 ohms is the largest. When compared to that, your equivalent resistor is larger than that. So compared to the largest individual resistor value, your equivalent resistor value is larger. Okay. All right. Next is actually the combination. What we're seeing is resistors in parallel. So what we're going to take is, right, across one end of the across one end of the resistors, we are going to connect it to a common point. Across the other end of the resistor, we're going to connect it to a common point. Okay. In this point, in this case, what will happen is, okay, the number of resistors are connected in between 2 common points, so that each of them will provide a separate path for current. Then we say they are connected in parallel. All right. So here, if you see, okay, let's say there is a resistor R1, right? There is a resistor R2, and there is a resistor R3. Okay, 3 resistors, and all 3 resistors, if you see, they are connected across to a common point, 2 common points, right? All of one end of the resistor is connected to one point, another end is connected to another point. Okay, then we say they are connected in parallel. Okay, now let's say you're connecting this whole of this across a battery. Right, now this being the positive and negative terminal of the battery, right? So here this particular battery has a voltage V, right? Now if you see, right, now the current flows through the positive terminal and ends over here, but as it goes into these branches, the current actually gets divided. So here the current flowing through this will be this, let's say this junction is A. From this point, the current flowing through will be I1, in this point it will be I2, and in this point it will be I3. Okay, and over here also it will be I1, I2 and I3, right? The current going in this point, in this terminal, it will actually get split into 3 branches. Here it will again split, whatever current is coming through at this point P over here, they combine and then they're coming to, you will have a current I. Okay, now if you look at the voltage drop, right? So if you want to look at the voltage drop across each of this conductor, resistor, so across this resistor you will connect to A and B. Voltage drop in this case also for AB you will connect across here. voltage drop for this also you will connect for AB across this end. So voltage drop in all these three cases will be V. Right? Voltage drop in all these three cases will be V. So what we see over here, voltage drop across all of these three resistors are same. So in parallel combination, voltage drop that we are seeing is same. Okay, because voltage drop is taken across the common point for all of these three resistors. Now, right? Now let's see. From we know V is basically, right? We know V is equal to IR, right? Here what did we see? What was common? Voltage was actually common, right? So here current through the resistor is changing, right? So I is nothing but V by R, okay? Now what is the current flowing through the first resistor over here, right? The current flowing through the first resistor will be voltage V, that is same for all three resistors, into resistor R1, right? Similarly, I2 will have a value of V by R2. I3 will also have a value of V by R3. So what is the final current? The current that is entering through this circuit, if you see, it enters here and then comes out also, the total current is I. But as it enters these different branches, this total current I gets divided into three branches, right? I1, I2 and I3, right? Current through each branch is different. So total current will be equal to the sum of the individual currents in each of the branches, right? So here what will be I1? I1 will be V by R1. I2 is V by R2. I3 is V by R3. Now, instead of all these three, right, what we are going to do, we are going to replace equivalent, whenever we are taking equivalent resistance, what we will do, instead of these three resistors, we are going to replace with a single resistor over here, connected across the battery V, right? So this particular equivalent resistor has a voltage V and current through it is I, right? The total current through it is I, right? So here what we can say, this particular resistor has an equivalent I through that particular circuit will be voltage by the equivalent resistance over here, right? Voltage, see, you can take voltage commonly out on each of these cases, right? And you can cancel that, and all you will have is 1 by the equivalent resistance will be 1 by R1 plus 1 by R2 plus 1 by R3. Okay, now from here what we can say, if you take, now we have taken only three resistors, but if they are multiple resistors and if they are connected in parallel, then the equivalent resistance in case of parallel combination will be sum of the reciprocal of the individual resistors. Okay, and if there are n number of resistors, each resistor you have to take the reciprocal of its resistance, and that will basically give you the equivalent resistance, and again this is also in reciprocal, right? Now the number of resistors that's connected in parallel, the reciprocal of equivalent resistance is parallel, in the parallel combination is equal to the sum of the reciprocal of individual resistance, right? Okay, now here if you see potential drop in case of parallel combination, potential drop is same. Whenever you're saying about total current, it is equal to the sum of the individual current in each of these branches. Alright, now if you take individual currents, these individual currents are inversely proportional to the resistance. Okay, and reciprocal of equivalent resistance will be equal to the sum of the reciprocal of individual resistance. That's what we see. So right now if you see, the equivalent resistance, if you see, is less than the smallest individual resistance. Okay, so in this case if you're seeing, let's take three resistors, right? Okay, let's say this resistor has a value of 1, this is 2 and this is 3. So when you're taking equivalent resistance in this case, you'll take 1 by 1, right? Then 1 by 2, then 1 by, let's say instead of 3, let's take 4, okay? 1 by 4. So this is 1, right? Plus 1 by 1 is 1, 1 by 2 is 0.5, 1 by 4 is 0.25, right? Now this value is equal to 1 by equivalent resistance. So combine all of this, you will get 1 by equivalent resistance in this case is 1.75. So equivalent resistance when you're taking, it will be 1 divided by 1.75, right? So 1 divided by 1.75 if you're seeking, right, that will basically give you a value of somewhere around 0.57 volts, right, ohms. That is the equivalent resistance. Now equivalent resistance when you're taking, that is lower that value if you're taking, right, this particular equivalent resistance is less than the smallest individual resistance that we have, right? So then this, okay, 1 second. Okay, here 1 divided by 4 when you're taking 0. I'm sorry, right. Then the lowest resistance that we have, than that the equivalent resistance in most cases will be lower. Okay, so these are the value. Why? Because you're taking reciprocal of that particular value. Alright, so this is all you need to know when you're doing resistors in combination. Now that we have seen this, guys, just give me 1 second. Now let's do some numerical based on the same. Okay, and all of these numericals I've taken it from your reference books. The book name is also given by the end of the slide, by the in the down below in the slide. Okay, so for example, let's say, okay, for example, we have a wire and this wire has a resistance of, for let's say 4R. Okay, now this particular wire is bent in the it's bent in the shape of a circle. Okay, now in this case, right, what will be the effective resistance in both the ends of the circle? Okay, so this particular wire has a value of 4R. So one part of this should be 2R and another part of this should be 2R, right? And we want to measure what is its equivalent resistance across its ends over here. Okay, if you want to find its equivalent resistance, we have to draw an equivalent circuit for this. So equivalent circuit for this will be, instead of this side, we are going to replace it by a small value, resistor 2R, and on this side we are going to replace it with the resistor of the same value, right, again 2R. So this is across the end A and B. Right, so instead of one end we are using this one, and instead of another end we are using this one. Right, now when this, if you see over here, this is actually the resistors are in parallel combination. So the effective resistance in case of parallel combination will be sum of the individual resistor, reciprocal of the sum of the individual resistors. Right, so here when you're taking the reciprocal of the sum of individual resistors in this case, let's rearrange this. Right, this will be R2 plus R1 by R1 R2. Okay, so R2 has a value of, let's say this is R2 and this is R1. Okay, R2 has a value of 2R, right, plus R1 has a value of 2R, divided by R1 has a value again here of 2R plus 2R. Right, so 1 by the effective resistance in parallel combination is equal to, in this case it is nothing but 4R by 2 plus, this is 2 into, right, this will be again 2 into 2 is 4, R into R is R square. So R, this cancels, right? So over here also 4 cancels. So we have 1 by Rp, this is equal to 1 by R. This is reciprocal of this equivalent resistance. So you have to take the reciprocal over here. So Rp will be equal to R. So the effective resistance for this combination will be R. Okay. And now let's say this particular R value has around 6, right? 16 ohms, right? Then in this case, our equivalent resistance that we will be using will be 16 ohms. Okay, now let's try one more. Let's try a few more numericals. After this, all we will be doing is only numericals. So if you have any questions also, you can ask. All right. Now, okay, now let's say we have a circuit. Here, the circuit is in such a form that, let's say there are resistors in these two arms, and there is a resistor in this arm as well. Okay, across these points where this meet, let's say this is A, let's say this point is B, and let's say this is C. Now across this B, we are going to take and we are going to connect a battery. Okay, and let's say the battery is 2 volts. So current is going to go through this place. It will branch out, current going through this arm. It will branch out over here, right, and it will come out over here, right. So here as it goes in, the current flows through, right. this current I gets divided into two branches, I1 and I2. Okay, and if you see here, I1 comes in, but if these two branches, if you see, they are connected in series. This resistor and this resistors are connected in series. The same current I2 will flow here, and when it comes out, I1 and I2 gets added and we get the total current I over here. Okay, so let's give the resistance value for all of these resistors, right? For example, let's say this particular resistor's value is 30 ohms, and let's say this resistor value is again 30 ohms, and let's say this is again 30 ohms over here, right? All three has same value, that is around 30 ohms. Okay, so now what will be the, let's find what is the current through the circuit. We don't want to find I1 and I2, we just want to find the total current I through the circuit. Okay, so if you want to find the total current I through the circuit, we want to find the total current I. This is what we want to find. If you want to find the total current I over here, first you have to find the equivalent resistance for this combination. Okay, so if you see the circuit, right now what we have is a 2 volts battery over here, and across the ends of the 2 volts battery we have a resistor connected, right? Now this point over here is actually what we can do in this case is, if you see over here we have two values, that is this one and this one, they are in series combination. Okay, so these two resistors can be added. Okay, let's say this is actually R1, and let's say this is R2, and let's say this is R3. Okay, now R1 and R2 are in series, so their equivalent resistance will be R1 plus R2, right? So that will be 30 plus 30 ohms in total, that is 60 ohms, right? Now 60 ohms resistance is the equivalent resistance between the arm A to B. Okay, now what happens, you can actually connect these two in actually you can connect them in series, right? Between the arm A, if you see, what you have is basically, right, so in this case if you see, we have one resistor which is around 30 ohms, which is your R3, right? This is your arm A, this is your arm B, right? Now across this A to B, these two resistors, we have found their equivalent resistance value to be around equivalent resistance to be 60 ohms. Now what do we have? We have two points, two resistors that are in series, parallel. Now for parallel, the effective combination will be taken as 1 by R3 plus 1 by the effective combination, in this case what you got, that is your effective combination in this case of series. Okay, so this will be 1 by 30 plus 1 by 60, right? Rearranging, you will get 1 by RP will be, right, 30 into 30 plus 60 divided by 30, in this case we have to, 30 into 60, right? This is 1 by RP, right? So take the reciprocal. If you want the parallel combination equivalent resistance, final resistance, that RP will be, take the inverse of it, right? 30 into 60 by 30 plus 60. 30 into 60, if you take it, you get around 1800 by 30 plus 60 will be 90. So cancel, 9 goes 2 times, right? 9 2s are 18. So here the equivalent resistance is 20 ohms. So instead of using these 3 resistors, right, instead of using all these 3 resistors, what you can do, you can just use one single resistor value over here, which is around 20 ohms. Okay, now that we know what is the resistor's value, total resistance, right, instead of this same circuit you can have where you're connecting this to a resistor which has a value of, alright, so in this case if you're taking, instead of all this, you can just take one single circuit. This is connected to a 2 volts battery, and you can have one single resistor which is around 20 ohms. And now you know what is the voltage value. Now you know what is the resistance R value, and you also know the voltage V. What will be the current I flowing through the circuit over here? Now we know V is equal to IR, right? So I will be V by R. What is voltage over here? That is 2 divided by resistance value over here is 20, right? That will give you around 1 by 10, that is around 0.1 amps you will get. Okay, this becomes your final value for the total current flowing in the circuit. Alright, now let's do one more, let's do a few more questions, right? Few more. Let's try one more numerical where, okay, let's say we have a battery voltage that is connected to, let's say this is 60 volts, alright, and across this we are connecting to a resistance R1 and it has a value of 18 ohms. Let's say this has a value of 18 ohms, right? From this end we are going to connect to another resistor. Let's say this is basically R2 and this particular value is 10 ohms. Okay, now other than this we are going to connect two more resistors, right? Across this point from here we are going to connect one more resistor. This is basically your R3, which is around 5 ohms, and across this there is one more resistor connected. Okay, this is basically your R4, which is 10 ohms. Okay, we just want to find, okay, equivalent resistance for all of this, right? Let's first find the equivalent resistance for all of this value. Okay, in this case if you see this, but these two are in series, right? These two resistors are actually in series over here, right? So you can combine their effective resistance, right? Their effective resistance, if you see in series, will be R3 plus R4, right? So that will be 5 plus 10, that is 15 ohms. Now this particular circuit, if you take, you can actually replace, instead of these two, you can replace one single resistor value, right? That is your RS, which is 15 ohms. Alright, now these two resistors are in parallel combination. Okay, so if these two resistors are in parallel combination, means you can take their equivalent resistance, but in this case the equivalent resistance in case of parallel combination will be 1 by Rp will be equal to 1 by R2 plus 1 by Rs, right? Let's rearrange this. This will be Rs plus R2 divided by Rs R2. This is 1 by Rp. So if you're taking Rp, that is inverse of this, right? Take the inverse of this particular value. So this particular resistor will be, right, R2 into Rs divided by R2 plus Rs, right? So here it is 10 into 15 divided by 10 plus 15, right? So this case, if you see, you get 150 divided by 25. So here 25 goes 6 times in 150, right? So you get 6 ohms. Now instead of these two resistors, you can just use one single resistor value, which is around 6 ohms. This effective resistance is around 6 ohms. Instead of those two, you can use this. Now if you see the total current, if you see this is R1 and R2, these are again in series, right? In this case, the final value, if you're taking in series, this is between R1 plus Rp, right? That is 18 ohms plus 6 ohms, that is 24 ohms. Okay, 24 ohms is the equivalent resistance. That is, instead of all of this, if you are actually using one single circuit, let's say there is a battery that is connected across this, current goes through it and comes back this direction, right? So here this voltage is 60 volts, okay, and here you can just use a resistor equivalent resistance of about 24 ohms. That is your final equivalent resistance value that you're getting in this case. Alright, now in this case over here, okay, let's take the current value, right? Now here we know the voltage, we know the resistance. So what will be the total current that is flowing through the circuit, right? So we know V is equal to IR, right? So I will be V by R. So voltage over here was 60 volts, right, by 24. So current I that is flowing through the circuit is 2.5 amps. Okay, so here the current flowing through the circuit I is going to be 2.5 amps. Okay, now knowing all this, if I connect a voltmeter over here, what will be the voltage drop across this resistor? We know the I value. We just found what is the I value over here, right? We found I to be equal to 2.5 amps, right? And we know this resistor is R. So this voltage, if you want to find, V is equal to I into R1. I we know is 2.5 amps, okay? R1 is nothing but 18 ohms. So your voltage will be, so I into R, right? So here you have to multiply. Okay, 2.5 into 18, you will get 45 volts. So the voltage drop across the resistance R wire will be around 45 ohms. Okay, now let's do one more question, right? Now let's say we have two metallic rods, right? We have two metallic rods, right? This particular rod has a resistivity rho 1, right? It has an area of cross section A1, okay? And we have another rod. That particular rod is made out of another material, so it has a resistivity R2, and in this case it has an area of cross section A2. But if you see, length of both the rods are same. Okay. Now let's say if you are connecting these two, right? If you're connecting across this two, you're connecting a DC battery, right? You're connecting a battery, right? Now what will be the effective resistivity of this particular combination? What will be the effective resistivity, right? In this case, we know effective resistance in case of this is one after another. This is, we can say, it's equivalent to having parallel combination. So that will be resistance for the first one by resistance for the second one, right? Now resistance and resistivity, how they are connected is resistance is equal to rho, right, L by A. So individual resistance, it has a resistivity rho 1, right, and into L, area of cross section, by A1. Similarly, this length of the wire is L, plus this one has rho 2, L by A2. Effective resistance, in case of these two, if you replace it by one single particular wire over here, right, then that wire will have an area A, right? You're replacing it with one single rod, it will have a resistance L, right? And its resistance will be, resistivity will be equivalent resistivity, right? So here in this case, this will have an equivalent resistivity of rho, right? And it will have a length L, but area of cross section in this case will be, you're combining both the rods. So that will have the area of cross section of A1 and A2 combined together will give you the area of cross section A over here. So area of cross section A over here will be the sum of both of these area of cross section of both the rods. Length in this case is same. Okay. Hello Akshay, whatever you're giving is actually right. Okay. Now this is 1 by RF, right? Now what you want is effective resistance. Effective resistance means then we will take the reciprocal of all of these values. Okay. Then you will have A1 plus A2 divided by rho effective resistance by L, because this is 1 by rho, right? We are taking the reciprocal of each of this value. Then this will be A1 by rho 1 into L, right? And then you will have A2 by rho 2 into L. What we are going to do, we are going to take L commonly out in both these cases, right? If you take L commonly out, you have 1 by L. Here also, you actually have 1 by L. In this one also, we have 1 by L, right? So, if you bring one of it to the other side, or since we have the same quantity on both sides, these two could be cancelled, right? So, this value can be removed. Okay. Now, from here, all we have to do is find what is the effective resistance, right? So, let's rearrange this particular equation, right? Here, you can actually, first of all, write this as one term, right? So, this will be A1 rho 2 plus A2 rho 1 divided by rho 1 into rho 2. From here, if you want effective resistance, let's bring this to the other side. So, the effective resistance will be equal to, let's cross multiply. Bring this term to the previous side. This will be rho 1, right? Rho 1, rho 2, okay, into A1 plus A2. This is on the other side, okay? We are actually bringing this term to this side and you're bringing this term to this side, okay? And whatever term is here, you bring it down, right? So that will be, right, let me just quickly do that separately. So in this case you have row 1 by row 1 row 2, right? Let's do this. A1 plus A2 into row 1 row 2 will be equal to A1 row 2 plus A2 row 1 into effective resistance, right? So effective resistance in this case will be what? Effective resistivity in this case will be what? Effective resistivity will be A1 plus A2, area of cross section of both the rods, into the resistivity, product of the resistivity, by, you have to add the area of resistivity with one of the conductor into the resistivity of the other one. So area of cross section of the second conductor with the resistivity of the next of the other conductor. Okay, so this basically gives you the effective resistance of this particular combination. All right, now with this note, let's actually try one more. Okay, well, let's try one more numerical. Right, let's say we have a resistance arrangement in shape of a alphabet A. Okay, so let's say this is A, let's say this is E, all right, and let's say across this also there is a particular resistor. Okay, let's say this point over here is B, and this point over here is C, and this point over here is D. Okay, this particular resistance, let's say this is R1, let's say this is R2, R3, right, R4 and R5, and let's say R5 has a resistance value of 10 ohms. Now this particular length of this particular length, if you take all together, let's say this overall length is 10 centimeters. Okay, and let's say this side also the overall length is 10 centimeters. Now the resistance per centimeter, okay, is around 1 ohm per centimeter. Okay, if the resistance value is 1 ohm per 10 centimeter, you have a 10 centimeter long wire or a resistance over here, right? So this particular one will have a resistance of about 10 ohms per centimeter. Let's say each of this is actually 1 per centimeter. So if one resistance per centimeter is around 1 ohm, then per 10 centimeter when you take the resistance value will go by will go by 10 ohms. Okay, so if I draw my resistance right now, I'll have a combination like this. Right, across this resistor, whatever we took, this is across the point A, across the point B. All right, now right now let's say this R1 has a value of 10 ohms. This is point B. R2 has again a value of 10 ohms. This has point C. Let's say R3 is again 10 ohms. Right, this is point D, and let's say this is point E, and the R4 is also again 10 ohms. Now this individual resistor in between is 5 ohms. All right, now we want to find what is the effective resistance across this end AE. Okay, if you want to find the effective resistance across this end AE, you have to find individual resistance. Okay, so first let's look at this. See, this point across BD, R2 and R3 are having a resistance in series. So here we can say two resistors that are in series, that is R2 plus R3. This will be 10 ohms plus 10 ohms. So what we get is 20 ohms in this combination. Okay, now this particular circuit becomes this way. Right? Right, A, E. Now this is R1, R2. This is R5. Across this, we have another equivalent resistance. Instead of two resistance, we can use this equivalent resistance 20 ohms. Now across this point B and D, there are two resistors that are in parallel combination. Right? There are two resistors that's in parallel combination. Now let's take parallel combination for both of them. So parallel combination will be, in this case, we have done multiple times, right? 1 by, in this case, the parallel combination will be 1 by R5 plus 1 by the resistance combination is in series, right? So R5, we know this is around 10 ohms. What we have taken over here is around 10 ohms. Okay. So R5 is around 10 ohms in this case. Okay. So this will be 1 by 10 plus 1 by 20. Alright. So to equate this, what we will do, we will multiply. Okay. So we will multiply this side by 2, right? Right. We will multiply this equation by 2 on both sides. So this will become 2 by 20 plus 1 by 20. This will be 3 by 20. This is 1 by Rp. So Rp means take inverse value, 20 by 3 ohms. Now, instead of these two resistors, we can use one single resistor which has a value, okay, which has a value 20 by 3 ohms. Alright. Now, if you look at the circuit, what has happened to the circuit is, it has just become into one single circuit, right? If you see, there are three resistors that are connected one next to the other, okay? Think if you want to stretch these three arms, right, you will have it this way. Let's say this is point A and this is R1 at 10 ohms, okay? This is point A, this is point B, right? Across point B to D, you have an equivalent resistance of value 20 by 3 ohms. Across D to E, we have an equivalent resistance of value R4, right? R4, which is around 10 ohms again. Okay, now all of this can be taken as series as 1. So now their effective resistance, if you see, will be R1 plus Rp, the parallel combination, plus R4, right? So this is 10 plus 20 by 3 plus 10. So if you actually find the value 20 by 3 and actually if you calculate, you will get somewhere around 26.67 ohms. Alright. So this will basically be the effective resistance value in this case. Alright. Now, so we have done this question and let's end today's class with one more question. Right. Let's do one more question and with that let us end today's class. Alright. So here let's say we have a combination given. Okay. Let's say now the resistors are connected in shape of a square. So the four sides of the square has 4 resistance. Okay. So in this case, let's take this to be side AB, right? C. Okay. And let's take this to be D. All right. Now, in the whole case over here, right? Let's say there is also a series connection in this direction over here. Let's take this R1 to be 10 ohms. Let's take this R2 to be another 5 ohms, right? Let's take R3 to be 7 ohms. Let's take R4 to be another 3 ohms and R5, the in between diagonal one resistor, to be 10 ohms again. Okay. Now, if you want to find the resistance value in all of these cases, and especially if you want to see what is the resistance across this part A to B, right? If you want to find what is the resistance across this part AB, right? Across this, if I am connecting, what is the resistor? So, to do that, we have to replace all of this resistor value, right? So, in this case, let's start from the beginning, right? Now, these two resistors are in series combination. So, in this case, if you take the series combination, R4 and R3 are in series combination. That is 3 ohms plus 7 ohms. So, RS, if you take, is around 10 ohms. Okay. Now, this particular resistor, if you see, you can connect it across to an equivalent resistor, right? Now this becomes your circuit. Okay. Now, if you see in this case, you have point AB, right? And this will be your R5 and this is your equivalent resistor value you found, that is 10 ohms. Okay. And this R5 and let's say this is R1 and R2. Now, across this point AC, if you take, right, there are two resistors that are actually in parallel combination, right? Now, you can actually do the parallel combination, find the effective resistance for those two. So, 1 by Rp will be 1 by Rs plus 1 by R5. So, Rp will be, right, Rs plus R5 right, Rs into R5 by Rs plus R5. So the effective resistance, if you take Rs in this value, has a value of 10 ohms. R5 is also 10. 10 into 10 by 10 plus 10. Right? So in this case, you will get 100 by 20. That is around 5 ohms. Now instead of these two resistors over here, you can just use one single resistor, right? Effective resistor over here. And in this case, that will be 5 ohms. Okay. This is again 5 ohms and this is again 10 ohms. Alright. Now if you see across this resistor, if you're seeing, there are two resistance that we are seeing that is in parallel. From A to B, if you see, from the point A to B, if you see, these two are actually parallel. Right. If they are in parallel combination means, right, their parallel, effective parallel resistance will be Rp plus R2. Right. So 5 plus 5 ohms. Now the parallel combination resistance we have got is 10 ohms. Now instead of these two, we can actually remove this and just give one single resistor value, right, which is actually 10 ohms. So finally the combination becomes such, we have a point A, across it there is one resistor and this is point B. Now across this we have another resistor. Now this is R1 which is at 10 ohms, right, and we also have another resistor which is the effective resistor which is again 10 ohms. Okay, now in this case, if you see, we have parallel combination. So the resistors across the RAB, which is your effective resistor, will be sum of these parallel combination of these two. When you have resistors in parallel, we can do R1 into Rp dash by R1 plus Rp dash, right? So the effective resistance, that is the resistance across the arm AB, if you want to connect an effective resistance, that value will be, right, in this case 10 into 10 because both have the same value, right, 10 plus 10. So that is 100 by 20, zeros cancel, 2 times 5, right? So that is 5 ohms. Now instead of all of this, across this resistor A and B, instead of connecting so many resistors across this arm AB, if you see, you can just connect a resistor of about 5 ohms. Alright, that will give you the value. Okay, with this note, we are ending the class today. If you have any doubts in what we have done till now, you can start asking in the chat box. Right, now we have an offer going on that is till July 29th. If you're taking any Express subscription for class 11 or 12, you can get 20% off on your ICSE Board Plus subscription. Okay, if you're taking for class 12, the longer duration you take, the course fees per month goes down. If you're taking for 9 months, you have to only pay 14,615 rupees. You're saving 2,578 rupees. If you're taking for a 1-year course, you only have to pay 16,868 rupees, and you only have to pay you will be saving around 2,975 rupees. Okay, to avail this particular discount. So if you're taking this 20% off, you have to either go for 9 months or 12 months subscription. Beyond that also, you can take 1.5 years or 2 years if you're in class 11. Okay, now if you're in class 12 or class 11, you to avail this 20% off and to get the subscription plans in this price, you can use my code MTIS10. Whenever you're taking a plus subscription, for example, let's say you're taking 1 year plus subscription, this amount that you're paying is for physics, chemistry, math and biology. All 4 subjects you're paying this amount in total. You can pay in installment if you're taking for 1 year and more, and also there is 0 cost on EMI available, offer available. 20% discount you want, use my code MTIS10. Now for class 12, we have a batch that is an ongoing batch, that is Achievers batch. That started on July 6th. The course is taught in English. For physics, we meet every 5:15 to 6:15, Monday, Wednesday and Friday. Okay. For math, Rahul sir will take. Chemistry, Manisha ma'am will take. Biology, Lakshay sir will take. The focus of your batch is the midterm syllabus coverage. After that, we will go with your term 2 syllabus. Alright. Next batch is actually your Brahmastra batch. This is for class 11. So if you are in class 11 and if you're taking the class 11 subscription, then if you do a payment for about 1 year and take class 11 subscription, your class 12 subscription is absolutely free. So right now at 20% discount, before 29th, if you're taking this particular subscription plan, if you're in class 11, you just have to pay for 1 year and you're getting 2 years plan. Okay, that is a very low price. Now for physics, we meet every 5:15 to 6:15 to Tuesday, Thursday and Saturday in case of class 11. Okay, and we are also introducing the community feature. You will never miss any update from your favorite educators. If you're following them, they are following their community, you can share your feedback directly via pool feature as well. Head down to the description box, look for the community link. If you go there, there will be some MCQ type questions asked. Please try them. It will be asked from the first 4 units. Please try them. any of the videos. If you find any inappropriate content and if you report the same, you can claim a prize. Alright, and if you like the class, please share it among your friends, subscribe to the channel, and also click on the bell icon to get notification. And I'll see you all in the next class.